Today, we're pulling back the curtain on a world you probably never think about: systems engineering. But forget about your typical apps or websites. We are diving deep into the hidden code that builds the very infrastructure we use to understand our justice system. So, let's just kick things off with a huge question, a real thinker. How do you even begin to measure justice? I mean, it sounds like something you debate in a philosophy class, right? How on earth do you put a number on something like that? Well, for a lot of policy researchers and, the engineers on the ground, the answer isn't found in philosophy books, it's in the data. If you can actually analyze the trends, look at arrests, sentencing, all of that, suddenly you can start to get a real, tangible picture of how the system is actually functioning. But here's the catch, and this is where our story really gets interesting. What happens when that data is just a complete and utter mess? We're talking about crucial information scattered across tons of different incompatible systems. Each one has its own weird formatting, its own errors, it's just digital chaos. And really, calling it a mess is an understatement. This is a data detective's nightmare. It's not just annoying, it's a massive wall that stops us from truly understanding what's going on. Imagine trying to solve a puzzle where all the pieces are from different boxes and don't fit together.
So here's what you've got to get your head around. A person's journey through the criminal justice system isn't one single story in one single computer. It's a series of totally disconnected episodes. The arrest, that's in the county jail system. The charges, that's in the state courts database. And if there's prison time, that's yet another system. They don't talk to each other.
And this is where it gets kind of wild. Look at this. It's so easy for one person to become two different people in the data. A simple typo, a date written a different way, using an initial instead of a full name, and boom. As far as the computers are concerned, John Smith and Jay Smith are two completely separate individuals. It's the same person, but the data says otherwise.
This right here, this quote, just nails the core of the problem. There is no unique person ID across these systems. Think about it. In almost every other part of your digital life, there's some kind of unique number, right? A customer ID, a social security number, something to tie it all together. Here, nothing. There's no magic key to link these records. The connection just isn't there. Okay, so how in the world do you fix this? How do you make sense of all this digital chaos? Well, this is where the really clever engineering starts. The answer isn't to try and change all those old government systems. That's impossible. The answer is to build something smarter on top of them. And the very first step, believe it or not, is to just embrace the mess. It's a strategy called Lake First. Instead of trying to clean up the data as it comes in, you do the opposite. You just grab everything, all the raw, messy, original data, every typo, every weird format, and you pour it all into one giant digital container, a data lake. Here's how that works in practice. You fetch the raw data. Maybe it's just the HTML of a court website, and you immediately store it in that lake. This is so important because now you have a perfect, untouched copy of the original. If you later try to clean it up and you make a mistake, no big deal. You just go back to that raw copy and try again. You never lose the original truth. Now, getting all this data is a delicate process. You can't just slam these government websites with requests. Many of them are running on old, fragile infrastructure. So engineers build what they call polite robots. These are programs designed to be super respectful. They have built-in speed limits, and they'll even automatically slow down if they sense the server is struggling. The last thing you want to do is accidentally knock a public service offline. All right, so we've collected all the messy data into our lake. That's step one. But we still have that big problem, right? How do we connect Jay Smith in one system to John Smith in another? It's time to solve the identity puzzle. And just to make things harder, this puzzle can get completely scrambled overnight. Take what happened in Oklahoma after the McGart v. Oklahoma Supreme Court ruling in 2020. The decision instantly shifted jurisdiction for a huge chunk of the state. Suddenly, cases that used to be in state databases started vanishing and reappearing in tribal and federal systems. The data landscape was completely fractured, making it impossible to compare past and present without a new solution.
So the breakthrough solution isn't about finding perfect, exact matches because we know those don't exist. Instead, it's a really smart statistical technique called probabilistic record linkage. It's a total shift in thinking. The system stops asking, are these two records identical? And starts asking a much better question. What are the chances, what's the probability that these two slightly different records are actually talking about the same human being?
And here's the cool part, how it actually works. It's like a digital detective looking for clues.
It uses fuzzy matching to catch typos in names. It uses phonetics to see if names sound the same, even if they're spelled differently. It looks for similar dates of birth, similar addresses. It takes all these little clues, weighs them, and calculates a match score. If the score is high enough, it clusters all those scattered records together and finally gives that person the one thing they never had, a single, unique ID.
This stuff it's just brilliant engineering, but it's so much more than a cool tech problem. The code we're talking about has a profound impact on real people's lives, and that means the engineers have a massive ethical responsibility on their shoulders.
Here's something really critical to understand. Data in the justice system isn't set in stone. It has a legal life cycle. A record can be sealed by a judge or even expunged entirely. It's not just a fact. It's a legal document whose status can change. And the software has to be smart enough to handle that.
And they do this with a really fascinating method called tombstoning. See, when a record is legally expunged, you can't just hit the delete key. You need to keep a record for auditing purposes to prove that you complied with the court order. So instead, the record is flagged with a tombstone. It's still there, but it becomes a digital ghost, completely invisible to any normal analysis, just as the law requires.
And all of this leads to a really powerful conclusion. In a system like this, privacy can't just be a policy you write down in a binder somewhere. It's not a suggestion. It has to be baked right into the very foundation of the software. Privacy has to be code. That means you have to plan for failure. You have to think like an attacker. I love this quote from one of the engineers. They talk about building a saboteur agent. It's literally a piece of code they write whose only purpose is to try and break their own system. It's an automated bad guy, constantly looking for weaknesses and gaps before the system ever goes live. That's a true security-first mindset.
So this brings us all the way back to where we started. Can we measure justice? Maybe not perfectly, but what we've seen is that through really thoughtful, ethical, and clever code, we can build a much more accurate and honest picture of the system we actually have. And having that clear picture is the first absolutely critical step toward making it better. So the final question is, what are we waiting for?